All right, so now hopefully we have some practice finding the area between curves. We're going to keep practicing because there are those little details about finding the endpoints and the switching points and all that. But we're going to add on one extra method that we have to consider. All right, I didn't do this initially because it just gives you too many options when you're first learning a process. All right, so adding this final method after we have a little bit of practice. All right, let's look at this area. All right, how would we find this area if we were doing it like we've been doing the other ones that we've been doing? I would have to break down this into different parts. All right, for every time there's a different function on the top and a function on the bottom, we're going to get a different area. So this one, we're kind of lucky in the sense that we always have the same function on the top, which is this horizontal line. But the function on the bottom changes. So in this section, we have this function on the bottom. All right, so that'd be one integral we have to set up. Here we set this straight line. I said to give us a different integral we'd have to set up. And here we have this line. We have a third one. So this is definitely possible to do the way that we discussed before. But it's going to be kind of inconvenient. We have to make multiple different integrals. We have to do a lot of antiderivatives and plugging numbers in. And of course, the more you plug things in, the more small mistakes can happen. All right, so we want to figure out another way we could do this problem that doesn't require us to do 3 separate integrals. All right, and the way we're going to do this is just turn your head to the side. Instead of thinking in the up-down direction like we've been doing all this time we're doing area, we're going to think in the left-right direction. So if I think in left to right direction, now if I turn my head to the side, this function here, let me use black since that's the line. All right, this black function is always farther away from the x-axis, and this green function here is always closer to the x-axis. So if I make my rectangles going this way instead, every single one of these rectangles has the same value of being the black function minus the green function. So our final method is basically going to be thinking about it in terms of our y-axis instead of our x-axis. So instead of making rectangles going this way, we're going to make rectangles going that way. And really, this is going to require us, A, to know to kind of do this because it's going to require us to use less integrals, and B, having to solve an equation so that we have it in terms of y instead of in terms of x. All right, so let's see how to do that in practice. All right, we actually already did this problem. All right, when we did this problem initially, we broke it up into 2 different regions. The left region has the red on top, the right region has the blue on top. All right, but now if we think about it from left to right, all these left to right regions have blue farther away and red closer. So that'll allow me to do this in 1 integral instead of 2 integrals. The only thing I need to do first is a little bit of prep work in that if y equals x squared, then x equals the square root of y. All right, so that's my red graph now is x equals y instead of y equals x. And if y equals 2 minus x, I could do subtract, that's add x, subtract y, x equals 2 minus y. All right, so the first thing you're going to do is, because we're changing what axis we're using, instead of having y equals, we want to get x equals. All right, so this is my red graph, and this is my blue graph. And now I can set up my 1 integral. At my 1 integral, what is the starting y value? Again, I'm thinking about y instead of x now. So my starting y value is at the bottom here. That's when the y value is 0. It stops at this y value there, and it's the y value 1. All right, so now if I'm turning my head to the side, I got to do that a lot. Luckily, I'm holding an iPad, so I can just turn the iPad. If you turn your head to the side, you can see it's from the y value 0 to the y value 1. My top function, and again, it's the one that's farther away, the bigger one. The one that's farther away from your y-axis is the blue function, which is 2 minus y. I'm going to subtract off the bottom function, which again is the one closer. That's the square root of y. And I can do that derivative or antiderivative. So if I find this integral, that's the same as doing it in 2 separate ways as before. But now we're thinking about it in terms of the y-axis instead of the x-axis. So if I take my antiderivative, all right, square root of y is y to the 1/2. It's going to be y So the 3/2 divided by 3/2 is the same as multiplying by 2/3. All right, so not much has changed in terms of how we do antiderivatives. Just because there's a y instead of an x, you still do the same techniques. Add 1 to the exponent, divide by the new exponent. There's a bunch of y's instead. And again, I'm going to pause the video here and work out all the details, all right, just so you can see the final answer. All right, so I plugged in all the numbers. This one's fairly simple because plugging in 1 and 0 are pretty much the easiest numbers to plug in. So 1 to any exponent is just 1, so all those simplify down. 0 just turns everything into 0, basically. And you simplify all this, and you get the answer of 5/6. And that's good news because this is the exact same answer we got the first time we did this problem. We thought about it in the x direction. All right, when we're thinking about in the x direction, we had to break it up into 2 separate integrals and do those kind of separately and add the answers together. Here, we had to do a little bit more prep work in that we had to rewrite all these functions in terms of y instead of in terms of x. But after that, it's just one integral, which saves you a little bit of time. All right, so again, some of these ones will have to be done in this method. This one, I was just kind of showing an example of you could do it 2 different ways. And technically, most of them you can do, but sometimes it's the difference between doing 1 integral in terms of y or like 5 integrals or something in terms of x. All right, so having this in your back pocket as another way to do areas between curves is useful. All right, so if you see the fact that you're going to have to break your integral into a lot of different parts, it might be benefit to turn your head to the side, see if you can think about it in terms of y instead of x, and do your area between your curve that way. All right, again, what we're going to do now in class is we're going to do more practice with this. So the practice problems will be similar to the practice problems we did before, but now we'll have this extra method. All right, some of the problems will ask you to do it in terms of y, so you get some practice. Other ones will just give you a generic area, and it'll be kind of up to you to determine, is it better to do it the way we did previously, just doing everything in terms of x, or will it be useful to kind of turn your head to the side and do it in terms of y? All right, but that's just more practice with finding the area between curves and kind of figuring out all the small details along the way.